All right, here we go. Day one of Actual Algebra 2 material, Unit 1, Day 1, solving absolute value equations. We're going to have two objectives today. First, we're going to talk about solving absolute value equations. So it's something you've seen before in Algebra 1, so just a quick refresher. An absolute value, those two horizontal bars are what the symbol for it is, returns the non-negative value of whatever is inside. So you can think of it kind of like how far away is what's inside from 0. What I mean by that is, if we look at this first example here, the absolute value of 3, 1, 2, 3, is still just 3. Doesn't change, because 3 is 3 spaces away from 0. But so is negative 3. So the absolute value of negative 3 is 1, 2, 3. So basically, whatever's inside, we return the non-negative version. If it's negative, it becomes positive. If it's positive, it stays positive. So the absolute value of negative 45 would be 45. The absolute value of 50 would be 50. The absolute value of negative 100 would be positive 100. And the absolute value of 4 would be 4. So that's just what an absolute value is. But things become tricky when we actually have to solve equations using absolute values. So go ahead and take a look. We're going to start with just a single variable here, just the absolute value of x equals 6. So the idea here is what values of x could make that a true statement. And it turns out there are two, because if you took the absolute value of regular 6, you'd have 6. If you took the absolute value of negative 6, you'd have 6. So there are actually two answers to this equation. So this is something that's going to be new, is that we can have equations with multiple answers, with no answers. In this case, there are two. We have x equals 6 or negative 6. Sometimes you'll see that as like a squiggly bracket, 6 comma negative 6. That means x is the set of solutions 6 and negative 6. Case number 2, if the absolute value of x is 0, that's the only case where there's only one solution, because the only thing that can go into an absolute value and come out a 0 is a 0. In the third case, the absolute value of x equals negative 10, this is what we call the no solutions case. Because if you think about it, if we put a 10 inside of an absolute value, we get out a 10. So that doesn't work. If we put in a negative 10, we get out a positive 10. There's no way to pull a negative 10 out of that absolute value, so this actually has what we would say no solutions. So we have no solutions there, and so key point number 2 is an absolute value equation with one variable may have 1, 2, or no solutions. If your absolute value ends up being set equal to a 0, one solution. If it ends up being set to a negative number, no solutions. There's no way to get a negative number out. And finally, if it's positive, two solutions, and that's where we'll spend most of our time. So if we have some more complex equations, so say we have the absolute value of 2x minus 4, then minus 2 equals 8, and we want to find what values of x make that a true statement. So just what I mean by a true statement, if x was 5, 2 times 5 would be 10, 10 minus 4 is 6, the absolute value of 6 is 6, minus 2 is 4. That's not 8. So 5 is not one of our solutions. We could keep guessing, numbers, but there's actually a systematic way to find this. The first step is always going to be to isolate the absolute value, meaning get it by itself. So if we want to get this absolute value equation by itself, the first thing we're going to do is move this over to the other side, plus 2, plus 2. So we move that over to the other side, and what we have left, we have the absolute value of 2x minus 4 equals 10. So we have an absolute value that is set equal to a positive number. Like we showed before, there are going to be two solutions. And so we're going to split into the two possibilities. We're going to have the positive possibility, either 2x minus 4 is already equal to 10, and the absolute value doesn't do anything, or 2x minus 4 is equal to negative 10. Because if it's equal to negative 10, the absolute value will turn it into positive 10, and it'll also be a correct solution. From here, we just have two-step equations to solve. We add 4 to both sides. We'd have 2x is equal to 14, dividing by 2. One of our solutions is x equals 7. And our other solution, when we quickly solve this, you have to watch out for your negatives here. Definitely feel free to use a calculator if you find yourself making a lot of mistakes here while you're getting re-warmed up. Negative 10 plus 4 is negative 6. And dividing by 2, we have x is equal to negative 3. The final step here is to check your answers. So you want to, even if it's just in your head, go ahead and plug them back in. So first, if we try 7, if we just think through, if we go back up to this top equation and we say, okay, 7 times 2 is 14, minus 4 is 10, absolute value stays 10, minus 2, yep, that's 8. So 7 is good. Second, negative 3. Okay, 2 times negative 3 is negative 6. Negative 6 minus 4 is negative 10. Becomes positive 10 when you do the absolute value. Minus 2 is 8. Great, negative 3 works out. So that could be on pen and paper. You could be actually taking these and plugging them all the way back in to x, or you could be just doing it in your head. Either way there is totally fine. But do make sure you're at least quickly checking that both of these work. Super key point here. The most common mistake that I find that people make here is they forget that they have to isolate the absolute value equation first. You must, the very first step, treat it like it's a variable, get that absolute value equation by itself, because that's when the split happens. It's okay, well, this is equal to, say, 10, so this was equal to either negative 10 or positive 10, but you can't do that until you've isolated. So 3 quick examples here. The absolute value of x minus 14 is already split up for us. I know there's 2 solutions because we have a positive and negative version. So we could have here the positive version, x plus 7 equals 14. Subtract 7 from both sides. That would make x is equal to 7. That's one solution. The other one, the negative solution, if x plus 7 was equal to negative 14, you're going to get a lot of practice with your negatives here. Subtract 7 from both sides. We'd have x is equal to negative 21. And if you check those ones both work out. On to the second one, the absolute value of 4x plus 7 equals 4. We need to isolate this first. So the first thing we need to do is subtract 7 from both sides. We get the absolute value of 4x is equal to negative 3. Doesn't matter what 4x is. There's no way to get a negative 3 to come on the outside of an absolute value function, so we are done. This actually has no solutions because there's no way when you take the absolute value of 4x, whatever it is, that it's going to be equal to negative 3. Finally, last one, wanted to throw one super spicy one that just has everything in there for you. You look at this and you might say, oh, equal to negative 73. Bam, no solutions, done. You have to isolate first, and this is a great example of why we have to isolate first. So the first thing we're going to do, I'm going to subtract 2 from both sides. That'll leave us with negative 5 times the absolute value of 5m minus 5 is equal to negative 75. And if you haven't yet, you're about to see what I mean. If you divide both sides by negative 5, because you have to isolate the absolute value, including any coefficients, you have to do that first, you're going to get the absolute value of 5m minus 5 is equal to a negative divided by a negative is a positive 15. So we will have 2 solutions. You're going to have to break this up into the positive and negative versions. On the one hand, 5m minus 5 could be equal to 15. On the other hand, 5m minus 5 could be equal to negative 15. So quickly solving these out, if we added 5 to both sides, we'd have 5m, 5 times some number is 20, and so dividing by 5, I'll just skip the step there, m would be 4. And then finally on the other side, very similar process, add 5 to both sides. 5 times some number is equal to negative 10, and so that number must be negative 2. You check those answers, you'd see that they both work for this problem. Number one key point here, you must isolate the absolute value first. All right. The next objective for today is to solve or to graph absolute value functions. And so we're going to start with just what the parent function looks like. The function f of x is equal to the absolute value of x. And the way I want us to approach this is by looking at a table of values. So let's say we had the absolute value of x and we plugged in negative 2. If a negative 2 goes in, a positive 2 comes out. If a negative 1, we'll do this in blue. If a negative 2 goes in, a positive 2 comes out. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So we could plot these points, right? X, f of x, that's the same thing as saying x comma y. So we have negative 2 comma 2, negative 1 comma 1, 0, 0, 1, 1, 2, 2. This is what your absolute value parent function is going to look like. It will have a vertex at 0, 0, and both of the lines that are coming off of it will have slopes. On the one hand, this slope is 1. On the other hand, this slope is negative 1. 1 is going up 1 over 1. 1 is going down 1 over 1. So that's what the parent function looks like. But we might make some changes to that function. So let's see if we had the absolute value of x minus 2 plus 3. Okay, now this is a little trickier. I'm just going to talk through it in my head. If we plug in 0, 0 minus 2 is negative 2. Absolute value becomes positive 2. Plus 3 gives us 5. Okay? If we plug in 1, 1 minus 2 is negative 1. The absolute value makes it positive 1. Plus 3 is 4. Okay? Plug in 2. Okay, 2 minus 2 is 0. 0, the absolute value is still 0, plus 3 is 3. This seems important here, and we're going to come back to it. Plug in 3. 3 minus 2 is 1. Plus 3 is 4. Finally, plug in 4. 4 minus 2 is 2. The absolute value stays 2. Plus 3 is 5. So here we go. We're going to have 0, 5. We'll do this one in red. We're going to have 0, 5, 1, 4, 2, 3. And then we start going back up again. 3, 4, 4, 5. Slopes of 1 and negative 1. The only thing that's happened here is this has shifted from the origin over 2 and up 3. We're going to learn about a lot of these different function transformations. And it turns out here that what this means is this minus 2 on the inside means we're going to shift to the right 2 spaces. And this plus 3 means we're going to shift up 2 spaces. But how did I know that those were the right points to pick? It turns out that what I did when I set this table up was I really thought about where is that vertex going to be. And that's how I'm going to just do these last 2 examples. You find out where the vertex is and you plot a couple points on either side. So let's take this example. If we wanted to graph the absolute value of x plus 4 minus 3, step 1 says to find the vertex of the equation by setting the absolute value expression equal to 0. So what that means is you take what's on the inside here, which is x plus 4, and you set it equal to 0. The reason that this is going to work, that this is going to help you find the right spot for this table, is that if x was any higher than negative 4, so say x is one side, either negative 5 or negative 3, on the inside of the absolute value, you either have negative 1 or positive 1, and they'll both spit out positive 1. So they'll give you the same thing that comes out of this absolute value. So we're going to have negative 4, and we're just going to go 2 points on either side. To the left would be negative 5 and negative 6. To the right would be 5 and 6. So you'll see what I mean here in a second. If we plug in negative 4, negative 6. Negative 6 plus 4 is negative 2. The absolute value makes it positive 2. And then minus 3 is negative 1. Okay, let's do negative 5. Negative 5 plus 4 is negative 1. The absolute value makes it positive 1. And 1 minus 3 is negative 2. Here's the key point. When we plug in negative 4, the absolute value portion is 0. And 0 minus 3 is negative 3. But when we cross over and we start going the other direction, now we're going to start counting up again. Because now instead of having negative 5 plus, oh, I'm sorry, here, now I see this. This should have been here. That didn't make any sense. This should have been negative 3 and negative 2. When we start going the other direction, when you plug in negative 3 plus 4 is positive 1. Minus 3 is negative 2. So we get this symmetry on either side. Plug in negative 2 plus 4 is positive 2. Minus 3 is negative 1. So we get this symmetry on either side. When we go ahead and plot this, negative 6 comma negative 1. It's a little off the graph here, but that's fine. Negative 6, negative 1. Negative 5, negative 2. Negative 4, negative 3. Negative 3, negative 2. Negative 2, negative 1. Here is the graph, roughly, of this absolute value equation. You're going to start to get to the point where you're just seeing the patterns, and we'll talk about this more when we talk about other functions. This is the absolute value function shifted left 4 spaces and down 3. Left 4 spaces and down 3. You don't need to memorize that right now. What I want you to focus on is finding the vertex. So last example here today, we'll do just like a super crazy example. If we had negative the absolute value of 2x minus 6 plus 2. Okay, so first step first, let's find the vertex. 2x minus 6. I want to know what value of x gives me 0 there so I can plot a couple points on either side. So we set this equal to 0, 2x is equal to 6, and x is equal to 3. 3 times 2, 6, minus 6, 0. So that tells us our vertex is at 3 comma something. We're going to do 2 points to the left, let's say 1 and 2, and 2 points to the right, 4 and 5. As long as we plot all of those points, we should have the vertex and a few points showing us the directions on either side. Okay, this one's going to be, I'm going to show this first one out plugging in. Let's say we actually plug in 1. Negative the absolute value of 2 times 1 minus 6 plus 2. Negative the absolute value of 2 minus 6, that's negative 4 plus 2. Negative, all right, the absolute value of negative 4 is positive 4 plus 2. See, there's the tricky part. That negative is on the outside. So it happens after the absolute value. So actually, it's like everything that's coming out of here is going to be negative. So what we're going to have is negative 4 plus 2 is negative 2. Okay? We'll do one more like that, and then the rest we'll do sort of just talking through it. Let's say we plugged in 2. We would have, we'll do it up here. So we have negative 2 times 2 minus 6 plus 2. Negative, we're going to have 4 minus 6 plus 2. Negative, the absolute value of negative 2 plus 2. Negative, positive 2 plus 2. This is actually equal to 0. Notice that the negative 2 becomes positive and then negative again because of that negative sign outside. So we have, in this case, when we plug in 2, we get 0. The rest we'll just do a little bit more quickly in our head. When we plug in 3, we already know the absolute value part is 0 plus 2 is 2. You might be able to already see the pattern that's going on here. We're going to start going back up the other direction, back down. When we plug in 4, looking at the absolute value, 2 times 4 is 8, minus 6 is 2. The absolute value stays 2, but then the negative out front turns its positive. Negative 2 plus 2, This is 0. And now lastly, we plug in 5. 2 times 5 is 10. Minus 6 is 4. Absolute value keeps it 4. But then that negative sign out front makes it -4 plus 2 to make -2. So we're going to get the symmetry that we imagined. We're going to plot these points, 1, -2, 2, 0, 3, 2, 4, 0, 5, -2. And so you can see there's a few things going on with this graph. Like I said, this example had everything. Wanted to show you the hardest possible version here. This had a few things going on. We were shifted to the right 3 spaces, up 2 spaces, and our graph was 2 things happened to our absolute value graph. Number 1, it flipped upside down. That's what that negative sign is doing. Number 2, it became steeper. Our slopes became 2 and -2 instead of 1, -1. We'll get practice with more of those. Those are tricky at first. That's why we focus on this key point here. So the last key point for today, the idea that you can graph any absolute value function by finding the vertex, which you find by setting the absolute value equal to 0, and then plugging in a couple points on either side. That'll get you your absolute value functions graphed.